Wonderful. Now let us do something which is of great importance. Welcome to a mathematics lesson video. This is specifically for grade 9s, but as well if you're grade 10, you will benefit if you watch this video. Now, today's lesson, it will be of interesting. Remember the previous video, we looked at directions, compass bearings. Now, today we are going to do bearings. Now, these bearings are called three-figure bearings or true bearings. Hence, you need to pay a particular attention because this is paper 1, section B, and it mostly carries 2 marks of your grade 9 final examinations. So now, let us begin by understanding what three-figure bearings are and what are the things that we need to know before we can attempt to answer the questions. Let's begin. True bearings or three-figure bearings. Now, the features of this, the features is what I want you to pay attention, because bearings, the three-figure bearings, the only thing that you need to not miss is the features. Once you understand what the features of the true bearing is, therefore now it means that the rest of the thing, it will be easy for you to work it out. Okay, the features of true bearings. Okay, let's begin. All angles are measured from north, meaning all angles are measured from north in a clockwise direction. Now, all angles are measured from north in a clockwise direction, meaning that your start point to measure the angle should be a north line. There should be a north line. So now, when you're measuring, when there's a north line, let's say this is my north line, and I want to measure this angle which is here. I cannot measure going anti-clockwise like this. That will not work for these bearings. But I need to measure going clockwise. Okay, this is clockwise. So meaning that I will measure going clockwise. In other words, this is clockwise and this is anti-clockwise. So we only measure from North Pole clockwise direction, not anti-clockwise. If you do that, then you are wrong automatically. Keep that in mind. Let's move on. All angles are written in 3 digits. All angles are written in 3 digits. For example, 72 degrees is not a bearing. Okay, it is just an angle. But if it is going to be a bearing, it's supposed to be 3 digits in how? 072 degrees. So if there was no 0 here, you have to include 0. Don't put 0 in front of 2. Don't put 0 this side. No, but put 0 at the beginning. Okay, then it will be 072 degrees. This is the bearing. So always remember, you write it in 3-figure bearings. 3 digits is very important. No wonder it is called 3-figure. No wonder it is 3-figure bearing. Okay, good. Let's move on to the next one. The bearing of A from B is never the same as the bearing of B from A. Keep in mind, A from B, they are simply telling you that you should come from B and go all the way where A is. And B from A, come from A and go to B. So these bearings can never be the same. They can never be the same. Okay? We shall look at it in the examples there. Now, before you answer the question, the example there, you need to understand certain rules, certain angles that will help you. So if you missed grade 8 in grade 8, if you didn't pay attention on angles, these angles are the ones you missed and they are very important. Now let me refresh your brains, or maybe help you before you answer these questions. Let's see. What are those triangles I need to know, that will help me in the bearings? If you are in grade 10, the triangles are very effective because the grade 10 is only triangles. But grade 9 will do with these angles. Okay, so equilateral triangle. An equilateral triangle is a triangle that has all equal sides. Okay, all equal sides. This side, they are all equal. But an isosceles triangle is a triangle that has 2 equal sides, meaning this angle, this side and this side is equal, and this angle and this angle, they are equal, but this side is not equal. That is an isosceles triangle. Now let's come to the angles which are more interested. Grade 8, 9, pay much attention. This kind of an angle, these are what we call perpendicular lines. If you did geometric constructions, you discover that perpendicular, you create these angles. So this line is a straight line, and this is a straight line which they are meeting at a point. Hence, they are formulating a 90 degrees. Remember in Pythagoras theorem, we looked at this kind of angle. So this kind of an angle is a 90 degrees. Now look at these lines. These are parallel lines. Okay, these are parallel lines. They can never meet. Even if you take them as far as you want, they can never cross meet each other. So now we are saying that parallel lines, angles in between parallel lines, they are equal. And now in this scenario, we are saying this angle and this angle, they are equal. If this was 20, even here it will be 20. Same applies here. Or this angle which is here is the same as this one. If this was x, then this is y, then we have x is equal to y, because these are alternate angles. Okay? This is what you need to know, because these are some of the questions that we are going to ask. You shall see how effective this parallel lines is. Now, a straight line, we know that a straight line curve like this adds up to 180. But the circle adds up to 360 degrees. Now, this is also where we have a transversal line. This is a transversal line, and we have two parallel lines. So, if two parallel lines are cut by transversal line, then we have alternate angles. Now, alternate angles are always equal. For example, B and B, they are equal. Same applies with A. If here was if this is A, then also here it will be A. But A and B, with these two angles, they should add up to 180 degrees. So if this was 20, I need to subtract 20 from 180, then I'll find B. That is how alternate angle work. Okay. Now let's move on again to another parallel line, of course, which I've explained here. Why, if you have two lines like this, you are formulating a Z. You see, this is a Z. When a transversal line cuts the two parallel lines, you formulate a Z shape. So Y and X, they are adding up to 180 degrees. Same applies with this one. This and this, they are alternate, so they are equal. Now, having looked at these basic angles and triangles that associate with bearings, now let's see if we can answer this question to prove that a bearing of A from B is not equal to bearing of B from A. For example, the bearing of A from B is 0.65 degrees. They have told us the bearing of A from B, 0.65 degrees. Illustrate the bearing and find the bearing of B from A. So they are telling us that they have given us the bearing, but they want us to illustrate it by drawing and showing that this is the bearing they are talking about. Once you do that, therefore now, go ahead and find the bearing of B from A. How do we do it? Let's begin. Solutions. So we write solution here. Okay. So the first thing is to illustrate the bearing of A from B. So what do? We're going to say, a bearing always starts from the ground level. They should be where it starts from. So let's say that this is my ground level, and this bearing we're talking about is from here to there. So let's say that this is my B, hence this will be my A. Okay? This point is my B, and this point is my A there. Okay? Therefore now, it means that they are telling me that the bearing of A from B, keep in mind, this is one thing I need to remind you. So pay attention on this one. If they say A from B and B from A, now they have given you one single line like this. One single line. Which line is my A and which line is my B? It's very interesting. They give you one line and they go A and B. So how can one line be A and B? No, that's not the truth. This line is either A, but it's not B. Meaning you have to come up with the B line or you have to come up with the A line. Okay, that is the secret here. So now you need to know where you are coming from. It is the line that they have not given you. So it means that you need to draw a line that you are going to come from. But the line that you are going to reach, to land on, That is the line they have given you. So how do you know? This is how you know. A from B. Where am I coming from? I'm coming from B. So they did give me the B line. So if this is if I want to find A from B in this manner, hence it means that the whole of this line, it is A. The whole of this line, it is the A line. Okay, this is the A line. Hence, I don't know my B line. So I need to generate a B line. Now, the B line, it is what we call the north line. So come up with the north line. So how do you come up with the north line? Where there is B here, draw a single straight line, or it can be a dotted line if you want. If you want, it can be a dotted line, or if you want to just leave it like this. Then you know that this is my north line. You have generated the B line. Hence, this becomes my B line. Because they never asked me for B line, so I've come up with the B line. So now they want me to show the bearing of 0.65 degrees. Remember, from B, we go all the way to A. So this is my B, and I'll go all the way to A line. So how am I going to move? I'm not going to go anti-clockwise. Remember, this is anti-clockwise, and this is wrong. They said we should go clockwise. So what is the correct way of me going to A? What is the correct movement? So the correct movement, it is starting from here, B, all the way to A. That is the angle they're talking about. And this angle, they said, it is 0.65 degrees. That is the bearing. And you are done. You see, I'm coming from B all the way to A. Hence, you are done with your bearing. That is how you identify. You see that? That is how you identify. So if you are able to show it like this, then it means that you have no problem. Now we shall come to the question which they are saying, find the bearing of B from A. So now this is BA. Now B from A, where am I coming from? I'm coming from A. So this line cannot be A anymore, but it will be B line. So I need to generate my A line. So let's demonstrate it here. Okay, let me do it here again. So you will see, now here we know the bearing of A from B, is it A from B is equal to 0.65 degrees. Now let us find the bearing of B from A. B from A. Let us find this bearing. So we need to generate again a line, the same line which is this one. Now we just make it here so that we don't look so dirty. So this is my B and this is my A. Now, here they are telling us that we should find a bearing of B from A. Now, B from A, I remember I said that from where you are coming from, it is a line that they never give you. So if they say from A, just know that A line is not given, but B line is the one that is given. So the whole of this line, it is what we call the B line. Okay, if the whole of this line is the B line, so let me just write it for Lily's sake. So this is B line now. Okay, this is B line. So I need to come from A. So from A, I need to draw a north line. We're exactly at the point where A is. They are saying that this is A. So I need to draw a straight line. Use your ruler and draw a straight line. You can draw a straight line from here. Okay, now this is not straight. Okay, let's draw a straight line from here. We draw a straight line. Yes. That is a straight line. And now this line, I can name it as the north line, or I can say this is my A what? A line. Okay, let me write the other side. This now becomes my A line. This is my A line now, for the sake of somebody to understand it better. That is my A line. I've generated my A line, which is the north pole line. Okay, it's a straight line. So I need to come from this line and I touch the B line. Remember they said we measure direction clockwise. So clockwise simply means this is my clockwise. I cannot go like this. If I go like this, then I'll be wrong. This is not this is anti-clockwise. Okay, this is if this direction is anti-clockwise and it's not allowed. So we need to go clockwise. So I'm going to start from A line. I move all the way to B line here. You see, I've touched my B line. That is the angle they're asking us to find. That is the angle they're asking us to find. So we don't know this angle. This angle we need to be able to find it. But keep in mind that they have given us this angle. This angle, they have told us that this angle from here, it is 0.65 degrees. It's 0.65 degrees. So how do I get to find this whole angle there? So here's a secret now. This line you have drawn, the A line, extend it so that it looks as if it should cut this angle. So let us extend this line. We extend this line like that. You see that? We have extended it. Now when you extend this line and you also extend this line here, what have you formulated? These two lines are the parallel lines. Look at this. These two lines, we have extended them, and you can see these, they're forming a parallel line. And now here, you are going to use the knowledge of these angles to answer that question. So how do we do it? We know that the angle which is here, this angle, x is equal to y, and b is equal to a. So, if this is 65 degrees, look at this, if this is 65 degrees, what is the angle which is here? This angle and this angle, they are equal. So this also, it is 65 degrees. Okay? Now, if this is 65 degrees, then look at this straight line. Okay? Let's look at this. Let me just draw a line like this, a straight line. Look at this line. If I remove 65 degrees here, I have from here all the way to there. What angle is this one? Let's come back to here. It's this one, which is 180 degrees. You see that? So it means that from here to there it is 65, but from here, okay, from here, which is from there to there, it is 180 degrees. 180 degrees. The angle from here, okay, there all the way to there, it is 180 degrees, but from here to there, it is 65, because this angle and this angle, they are equal. So if this is 65, also there it is 65. But a straight line adds up to 180 degrees. So now, the bearing they are asking us is from this angle, the whole of this angle to there. So what do you think we'll do now? What do you think we'll do? We are going to add the two angles. Let's add the two angles. So we are saying that the bearing from B from A is equal to 180 degrees. 180 degrees plus what? 65 degrees. 180 plus 65 degrees. That will be the bearing. Now let us add that and we see what we get. So what do we get? What is our answer? We are going to say 180 plus 65. So, okay, what is 0 plus 5? That is 5. Okay, 6 plus 8, 8, 9, 10, 11, 12, 13, 14, which is 14. So we have 4 remainder 1. 1 plus 1, which is 2. We have 245 degrees. So 245 degrees is a bearing. Now look at this bearing. You don't have to put 0 here because it is already in three figure digits. Okay, so you leave it just the way it is. So the bearing from the bearing of B from A is equal to 245 degrees. So this is how you answer these kind of bearings. Okay, this is how you answer these bearings. And now, I will ask you to pause the video, copy this in your notebook, and now be ready for the next video, which of course will be exactly question from past paper. We shall start from 2022 going to all the way down. You see how they come, just like this. So this concept is very important. If you have not understood, watch the video over and over until you understand it, until you see what is happening here. Therefore now you will have a beautiful day. Okay, don't watch the video and leave it without understanding. It means that you have done nothing. No wonder it's a video. You can pause it, you can slow down it, you can do all those kind of settings so that you get to know what is happening. Okay, So this is how you work out the three-figure bearings. Please do like the video, do comment, and do subscribe on my YouTube channel so that you can get to be notified each and every time I post a new video. Now, the next video will be of ECZ examination questions. Don't miss, because it is going to be super nice. I love you all. Enjoy your day. Bye-bye.